Welcome to Maths Companion. I am Ramesh. In the last video, we have discussed 5 problems of page 42 and there were 2 homeworks. Let us check the answers now. The first problem, O is the center of the circle, AD and BC are perpendicular to XY. CB cuts the circle at E. Prove that CE equal to AD. Let us look at the figure at first. Given that O is the center of the circle, AD and BC are perpendicular to XY and CB cuts the circle at E. We have to prove that CE and AD are equal. First of all, let me join A and E. Now what is this angle? Angle AEB. It is 90 degree because it is in this semicircle. So we can say angle AEB equal to 90 degree. Then what about this angle? That is also 90 degree. We know the sum of these two angles is 180 degree. Since this angle is 90 degree, angle AEC is also equal to 90 degree. This angle is 90 degree. Angle C is also 90 degree. Now we got this angle is also 90 degree. Then what about this angle? That angle is also equal to 90 degree because sum of all the 4 angles of a quadrilateral is 360 degree. So we got all the 4 angles of this quadrilateral are 90 degree. That means it is a rectangle. Now we know opposite sides of a rectangle are equal. AD and CE are opposite sides of this rectangle. So they are equal. So we can say AD equal to CE. Now the second problem. In triangle ABC, angle A equal to 30 degree, angle B equal to 60 degree. If we draw a circle with AB as diameter, say whether it will pass through C. Why? Angle A equal to 30 degree. Angle B equal to 60 degree. Then what is angle C? That is equal to 90 degree. Because we know sum of all the 3 angles of a triangle is 180 degree. Now let us draw a rough figure. Angle C is 90 degree. So this angle is 90 degree or this angle is C. Now look at the figure. Suppose we draw a circle with AB as diameter. Will it pass through C? Definitely, because it is a right angle. Therefore, the circle with a diameter AB passes through the point C. Now let us do the remaining problems of page 43. Sixth problem. The 2 circles in the picture cross each other at A and B. The points P and Q are the other ends of the diameters through A. Prove that PBQ lie on a line. Prove that PQ is parallel to the line joining the centers of the circles and is twice as long as this line. First of all, we have to prove that P, B and Q are on a line. How can we prove 3 points are on a line? Let us see. Look at the points A, B and C. Are they on a same line? No. When you join A to B, it is a line, and when you join B to C, it is a different line. Now look at the angle between them. The angle between these 2 lines is 38 degree now. Now let me increase the angle. Now the angle between these 2 lines is 77 degree. Are the points ABC on the same line? No. Let me increase the angle again and observe the points ABC. Are they on the same line? No. Let me increase again, observe the points. Are they on the same line now? Yes, A, B, C are on the same line now. Now what is the angle between these two lines? That is 180 degree now. That means when the angle between these two lines is 180 degree, the points A, B, C are on the same line. So in order to prove that the 3 points are on a line, it is enough to prove that the angle between the lines is 180 degree. Now let us look at the figure at first. We have to prove that P, B and Q are on a line. So it is enough to prove that the angle between PB and BQ is 180 degree. Let me join PB at first. Now let me join A to B. What is this angle? It is 90 degree because that angle is in this semicircle. So we can say angle ABP equal to 90 degree. Now let me join Q to B. What is this angle? That is also 90 degree because it is in this semicircle. So we can say angle ABQ equal to 90 degree. Now we can say angle ABP plus angle ABQ equal to 180 degree. What is the angle between PB and BQ? Up to this line AB, it is 90 degree. From that line to BQ, it is again 90 degree. And therefore, we can say the angle between PB and BQ is angle ABP plus angle ABQ. And we have seen that angle ABP plus angle ABQ equal to 180 degree. That means the angle between PB and BQ is 180 degree. Therefore, the points P, B and Q lie on a line. Now the second part, prove that PQ is parallel to the line joining the centers of the circles and is twice as long as this line. Let C and D be the centers of the circles. Let C be the center of this small circle. Means C is the midpoint of this diameter AP, or C is the midpoint of the side AP of triangle APQ. In the same way, D is the center of this circle, means D is the midpoint of this diameter, or D is the midpoint of the side AQ of triangle APQ. Now let us look at triangle APQ. C and D are midpoints of two sides. When we join them, we get the line CD, and we know the line joining the midpoints of two sides of a triangle is parallel to the third side, and the length of that line is half the length of the third side. That means CD is parallel to PQ and it is half of PQ. When CD is parallel to PQ, we can say PQ is parallel to CD. When CD is half of PQ, we can say PQ is 2 times CD. So we can say PQ is parallel to CD and is twice as long as CD. Seventh problem, prove that the two circles drawn on the two equal sides of an isosceles triangle as diameters pass through the midpoint of the third side. Let us take an isosceles triangle at first. Let ABC be an isosceles triangle in which AB and AC are equal. Now let me draw a perpendicular from A to BC. Let it meet at D. Then we know D is the midpoint of BC because in 8th standard we have seen that in an isosceles triangle, the perpendicular drawn from the vertex joining equal sides to the opposite side bisect the opposite side, or the perpendicular passes through the midpoint of the opposite side. That means D is the midpoint of BC. Now AD is perpendicular to BC, therefore these two angles are 90 degree. that is angle ADB and angle ADC is 90 degree. Now suppose we draw a circle with AB as diameter. Then it passes through the point D because angle ADB is a right angle. In the same way, if you draw a circle with AC as diameter, it passes through the point D because angle ADC is 90 degree. Therefore, we can say the circles with diameter AB and AC passes through the point D. Now we know AB and AC are equal sides and D is the midpoint of the third side. So we can say the circles drawn on the two equal sides of an isosceles triangle as diameters pass through the midpoint of the third side. Eighth problem. Prove that all four circles drawn with the sides of a rhombus as diameters pass through a common point. Prove that this is true for any quadrilateral with adjacent sides equal as in the picture. Let us take first part of the problem. Let us give a name for convenience. Given that ABCD is a rhombus, therefore all the four sides are equal. Now let us join AC. Then we get two isosceles triangles. ADC is an isosceles triangle and ABC is another isosceles triangle because we know these two sides are equal and these two sides are equal. Now, in the last problem we have seen that the circles drawn on the two equal sides of an isosceles triangle as diameters pass through the midpoint of the third side. Triangle ADC is an isosceles triangle and AD and CD are equal sides. So the circles drawn with AD and CD as diameters pass through the midpoint of AC. In the same way, ABC is another isosceles triangle and AB and BC are equal sides. Therefore, the circles with AB and BC as diameters pass through the midpoint of AC. That means all the four circles pass through the midpoint of AC or they pass through a common point. Now the second part, PQRS is a quadrilateral in which the adjacent sides are equal. That is PQ equal to PS and RQ equal to RS. Now let us join QS. Then we get two isosceles triangles. Triangle PQS and triangle RQS. We know PS and PQ are equal and RQ and RS are equal. Therefore, these two triangles are isosceles triangles. And we have seen that the circles drawn with equal sides of an isosceles triangle as diameters pass through the midpoint of the third side. Therefore, the circles with the diameters PQ and PS pass through the midpoint of QS. In the same way, triangle RQS is another isosceles triangle and RS and RQ are equal. Therefore, the circles with the diameters RQ and RS pass through the midpoint of QS. That means all the four circles pass through the midpoint of QS or they pass through a common point. Ninth problem. A triangle is drawn by joining a point on a semicircle to the ends of the diameter. Then semicircles are drawn with the other two sides as diameter. Prove that the sum of the areas of the blue and red crescents in the second picture is equal to the area of the triangle. Here, this is a semicircle and the ends of the diameters are joined to a point on the circle and we got a right angle triangle. Then semicircles with these perpendicular sides as diameters are drawn and we have to prove that sum of the areas of these two crescents equal to the area of the triangle. Let us take the figure at first. Let me give a name for the triangle. Now there are three semicircles. What is the area of this semicircle? That is the area of the semicircle with diameter AB. Area of a circle is pi r square. Therefore, area of a semicircle is half pi r square. What is the radius here? Diameter is AB. Therefore, radius is half of AB or AB by 2. Therefore, area of the semicircle with the diameter AB is half pi into AB by 2 all square. Now, what is the area of the semicircle with the diameter AC? Half pi r square, and r is or radius is AC by 2. So, we can write it as half pi into AC by 2 all square. Now, what is the area of the semicircle with diameter BC? R is BC by 2. So, we can write it as half pi into BC by 2 all square. Now, let us add the areas of these two semicircles, that is the red and blue semicircles. Sum of the areas of blue and red semicircles. Blue semicircle is the semicircle with a diameter AC, and red semicircle is the semicircle with a diameter BC. And the sum of the areas is half pi into AC by 2 all square plus half pi into BC by 2 all square. Half pi is common in both the terms, so we can take it outside and we can write it as half pi into AC by 2 all square plus BC by 2 all square. Now, AC by 2 all square is AC square by 4 and BC by 2 all square is BC square by 4. So, we can write it as half pi into AC square by 4 plus BC square by 4. Here, the denominator is 4. The denominators are same. So, let us add it together and put the common denominator. So, we can write it as half pi into AC square plus BC square all divided by 4. Now, what is AC square plus BC square? Let us look at the figure. AC square plus BC square. These are the perpendicular sides of the right angle triangle or base and height. And we know base square plus height square equal to hypotenuse square. Therefore, AC square plus BC square is equal to AB square. So, replacing AC square plus BC square by AB square, we can write half pi into AB square by 4. This is half pi into AB by 2 all square, or the area of the semicircle with diameter AB. That is, the sum of the areas of the smaller semicircles is the area of the large semicircle. Now, let us look at the figure once again. We have seen that sum of the areas of the blue and red semicircles is the area of the large semicircle. Suppose I remove this part from the blue semicircle. Then we get the blue crescent. At the same time, a part of the large semicircle is also removed because that is the common part. Similarly, let me remove this part from the red semicircle. Then we got the red crescent. At the same time, a part from the large semicircle is also removed. That means the portion removed from these two semicircles is also removed from the large semicircle. Since the sum of the areas of these two semicircles is equal to the area of the large semicircle and the same portion is removed from both, sum of the areas of the blue and red crescents is equal to the area of the triangle. So we have completed the first section, right angle and circle. We have discussed all the ideas and we have done all the problems. I have given you some additional problems also. So learn well, practice well so that the ideas are very clear. It will help you to understand the next part. Learn at regular intervals so that you can remember it forever. If you have any doubts, ask your teachers or comment it to me. In the next video, we will discuss the next part. Till then, bye.